all of you. My name is Shreya Agrawal, and I will be the host of this evening for the first part of the event. This is our 25th event, and it is the spring is coming event. We can all see in the weather that it's bright and sunny for the last couple of days, and we're so excited. I think when the sun is out, the city just comes to life in Berlin. So thank you for joining in and deciding to be a part of this event today. Before we start with the sessions, we have two exciting sessions planned for the evening. Before that, I will quickly like to talk to you all about why PyBerlin. And that is because we all love Python and we're all in Berlin. And when the Python, that is the snake, came to Berlin, it climbed the TV tower because it loved Berlin so much. And that's why as a hobby, we also started this platform of PyBerlin and want to be more present in Berlin and help the Python Berlin community here grow and share ideas. Like I was saying, we all love Python and we love sharing ideas. We are based in Berlin and we welcome everyone who is interested. The organizers, we have Anastasia, who is handling the streaming platform as usual. Thank you, Anastasia, for making this possible. Today's event is both on Zoom and on Twitch. Then there is myself, who will be your host for the evening, along with Theo Kostia, whom you will be seeing in the second part of the event. Thanks everyone for joining. This is our 11th online event. I think we started in April 2020 when Corona happened. And since then, we're very proud to let you know that every month we have organized an event, a successful event, and we've seen audience, people like you join in, and we're very grateful for all of you to be part of this journey. And we look forward to having you back on our platform in future as well. And we don't have many rules, but one thing that is super important for us is that we should be nice to each other, be patient as well a little bit, because sometimes in these online events, the streaming platforms, or there could be some technical issues, but we just request you to be nice. There are, of course, more guidelines available, and if you're interested, you can read our code of conduct on the link mentioned on your screen. It is a very safe place to ask questions. There is no big, small, or stupid question. We welcome all questions. There is no feigning surprises or, well, actually, and no subtle isms. By isms, we refer to sexism, racism, or any form of discrimination. We are a very open society and we welcome everyone to use our platform to grow, to share their ideas and be part of a bigger community, a Python community in Berlin. Today's event is sponsored by ScoutBee, that was made possible by Anastasia, who works there. So thank you, Anastasia and ScoutBee, for sponsoring our Zoom platform and making it easier for us to reach out to more people in Berlin. Today's agenda, we have two exciting speakers lined up for today. Our first speaker is Luben Alexandrov, who will be talking about good practices for the development of algorithmic systems. And our second speaker is Vinicius Ferreira. I'm sorry if I'm not pronouncing the name perfectly, but he will be talking about better functional tests with APIs and Behave. Also, we are looking for organizers. If you're interested in organizing these events, they are mainly online right now. And if you want to know how streaming works or how does setting up this whole event, coordinating between Twitter, Twitch, Zoom, and Slido and different platforms, and choosing which is the good platform or what works for us. If you're interested in learning about this, please reach out to us on Meetup, on Twitter, or any way, and we would be happy to have you on board and help us organize the events in online and also in person in future. At the same time, we're also looking for speakers, but when we say speakers, do we mean professional speakers? I don't think so. By speakers, we mean anyone who has something to share and is wanting to use our platform to talk about their work or just practice their presentation skills as well. And we will be happy to have everyone who is interested to present their work to use our platform and share their ideas. There are two formats. There is one long talk of 30 minutes with or without Q&A. And then there is shorter talks of 5 to 10 minutes called as lightning talks, where you can just talk about some interesting idea you had, or a quick walkthrough of some interesting work that you are doing, and you can use this platform to share your ideas. If you're interested, then please submit your talk proposal here. In fact, you can reach out to us on our meetup page via messages or on Twitter, or just say hi to one of the organizers and let us know that you're interested, and we will make it possible as per mutual convenience. Our next meetup is on March 10th, and it's a special event. It's to celebrate International Women's Day, and we have some exciting sessions as well as a small Q&A plan for our speakers. So it's a Wednesday, and we'll really look forward to having you on that special occasion and sharing and listening to different perspectives on what it means to be a part of this community that is constantly growing and trying to become more and more inclusive. Along with that, we will also have, as usual, technical sessions planned for you, and we really look forward to having you for this special event on March 10th. And also, we are on Twitter by the handle PyBerlin Python, and we would love to hear what you have to say about our event, our platform, or if you have any feedback for us. So if you would like to mention about us on Twitter, we would really love that. And please, when you do that, don't forget to tag us with the handle PyBerlin Python. We're also on Slack with the Berlin Python community, and the link is mentioned on your screen by Python Berlin slack.herokuapp.com. Also, we would like to give out a huge shout out to some platforms and some people who made all these interesting slides and logos possible. The free assets and resources was created using Slides, Carnival, and Unsplash. And people who helped with the logo and story was Elena, Konstantin, and Christian Barra. So thank you guys so much. And because of you, we are making this event possible even after, I think, more than 2 years. So thank you so much. And we look forward to future collaborations as well. And with that, I would like to talk about our first speaker, Luben Alexandrov. Luben is a programmer or software architect who in his spare time acts as the CEO of Berlik Soft. He studied computer science in Karlsruhe Institute of Technology, where he did research in the area of algorithms for matrix multiplication. In the last years, he has been focusing on helping companies with complex software projects. Today, Luben will be talking about good practices for the development of algorithmic systems. So very happy to have you, Luben, and over to you. So welcome, and please start with your session. Thank you so much.
Yes, thank you, Shreya. Happy to be here. So I'll share my slides now. To the talk, I will talk to you now about good practices for the development of algorithmic systems, as already stated. So I'll present to you some research we did with my colleague Dennis last year about what could be good practices for development of such systems. First of all, I want to thank the organizers for making these meetups possible. So I know that you guys probably, you do this in your free time, you sacrifice maybe lunches to make these things happen. So really, I think it's very important, very good for a community to have these venues, even more so nowadays. Thank you for that. Back to the presentation, just a heads up, before we go into the practices themselves, I'll need to put the stage for you. So I'll need a few slides for that. All right, so algorithmic systems, what do I mean by that? In software, you have these fields. You have software engineering, where you care about creating a robust application, which is used by real users. And you have also research, where you maybe care about examining some phenomena, or maybe designing algorithms and doing experimental development. So experimenting. There is also an intersection between these two, where you are designing your product, but you're not sure what the right path is. So you would need some experimentation there. And this is what we mean here in this presentation, at least as algorithmic systems. Here are some examples for you for what could be systems like that. So autonomous driving, very, very popular nowadays. Systems with natural language processing, robotics, computer vision systems, data and discovering knowledge from data, but also maybe a bit forgotten algorithmic systems that are still heavily used, like search or routing applications, how to get from point A to point B. And maybe also other fields. I'm sure some of you are working on projects or have been working on projects which may fall in a category which is regarded as an algorithmic system. So the first statement that I want to give you is that there is actually a lot of research when it comes to algorithms. And the justification for this is this chart here, where we see number of accepted papers at the Neuro IPS conference. It's a very popular conference nowadays, used with neural networks. And we can see in the past 4 years, the number of accepted papers is increasing so quite rapidly. And there are also other conferences. So there is a lot of research when it comes to algorithms. However, we were surprised to see in our review that actually there is not so much when it comes to the process of engineering these algorithms or algorithmic systems. At the same time, process is an important part of success. I hope you agree with me. If you have a good process, this will lead you to hopefully to a better product, or it will lead you faster to your product. So some good practices could help. I want to open a bit of a side note here because I think it's important. I think it's important to ask ourselves what are actually good practices and if a practice is actually good and what are the justifications for that. So there is a lot of literature, actually there are a lot of books, blog posts, meetups as this one, where practices are discussed, which is obviously good, but to have something accepted widely as a good practice, and it has some justification more than that. So I just want to make you a bit aware, or if you're probably you are already aware, but just to put it in this presentation, that there is a difference between gut feeling and data. So if you have data that you justify the benefit of a practice is obviously more powerful than just a gut feeling. Unfortunately, this presentation falls more in the gut feeling part. So those are our thoughts, but nevertheless, we thought it, we wanted to get some feedback on it, and hopefully this meetup is a good forum for it. Still, there are, I gathered some venues here for you where practices, software practices are being discussed. Obviously, meetups are great because you can have a discussion. I find it really unfortunate that we can't do it live, but hey, we do what we can in the moment. But there are also conferences, like for example, this one, ICSI, it's quite old, I would say. This year takes time in May, end of May. And there are also journals where there are papers for software practices are published, and there is more data there, so a bit of more justification. Okay, so back to the topic of algorithmic systems and practices for that. When we talk about practices and process, maybe you're an engineer, data scientist, or a manager of an engineering team. So you would ask yourself, okay, what would I get from a process or from good practices? And I think you can get two things, quality and speed. So you can get a better product, for example, less bugs in your software. And hopefully you can get faster to where you want to go to your product. So the practices that I will present are oriented more towards the speed part. Although some of them could help with the quality as well. All right, so let's dive into it. Just to put some maybe terms that would help us, something very considered a cornerstone really in research, which shouldn't go unnoticed, I would say, is falsifiable hypothesis. So remember, these systems that we're building, they're software systems, but they have this part of experimental software systems, if you will. And because they touch on research and science, they would benefit from using some concepts from there. And one concept is falsifiable hypothesis. It was introduced by Karl Popper, his book, Logik der Forschung. It's quite an old book, translated in English as well. And it means, according at least to online dictionaries, able to be proved to be false. So I got the book actually. I tried to translate what the definition that Karl Popper gives from German to English, and this is my best try. I hope it's correct. So a theory is falsifiable if the set of options that can prove it false is not empty. So it's more or less saying the same thing as the statement above, but in a bit more formal way, let's say that way. So how can we interpret that? Well, we can interpret it, at least I interpret it with this thought. So when you have a hypothesis, and it is falsifiable if you can conduct the experiment, you can measure the result of the experiment, and the result can contradict the hypothesis. And the example which is given in the book by Popper is that for a hypothesis is all ravens are black. So if we find a raven which is white, this will make the hypothesis false. So we can actually have an experiment that proves the hypothesis false. Just to give you an example. So going a bit more in the review of what is already out there, Sanders introduces a cycle for algorithm engineering in his paper, and it's very related to the falsifiable hypothesis, to Popper's hypothesis. It starts with a falsifiable hypothesis, and then we can design our solution, our algorithm. We can analyze it. For example, we can do complexity analysis. We implement it, and then we do an experiment. And with evaluating the experiment will lead us to contradicting the hypothesis or supporting it, and then go into another cycle with a bit updated hypothesis maybe. So this has been already there, and I think if you work in the machine learning area, even without realizing it or with realizing it, you are your workflow is related to this cycle. So you have a hypothesis, let's say you have a model and features, and you think that these features will improve the performance of your model, and you implement it, then you experiment, evaluate, and see if it's true or not true. So I think, yeah, this is really good because it formalizes how you would go towards experimental software engineering. But we thought we can maybe add some points which are from practical perspective beneficial. And here we come to our practices. So the first one that I want to know is when you're confronted with designing such system, it's really important to find the state of the art. As we saw, there is a lot of research already there, and no matter how novel your area it is, I bet that there is already something out there that you can at least evaluate sometimes it might be that the state of the art is already good enough and you don't need to invest more research. You can take it. And if you start from the state of the art, then you're starting from a really high bar. You don't need to reinvent the wheel. Next point that I believe is very beneficial is to work in a team. So remember, these systems are still software systems, so they benefit from the same ideas that we have for software systems. As the same way we get review for our code in code reviews, we could get review for our hypothesis in experimental software engineering. And this leads me to the next point. So it's good and crucial, I believe, actually, to formulate your hypothesis when you do your experiments. This will help you to formalize what are you actually trying to prove or disprove, and will help you to communicate with your colleagues when you're working in a team. And now it comes a part which is related to speed as well. So you might have in your system a lot of options that you want to experiment. And you might not have the time to do all of the experiments. So when you formulate your hypothesis, here, even without conducting the experiment, you can try to challenge it in your team. So try to say, okay, this hypothesis, it doesn't make sense for us to do an experiment because we know already that it's really unlikely that we will lead to a good result. So this will save you time if you, or you can deprioritize this experiment. Another way to get faster to your destination is to keep focus on the main problem. So these systems tend to be complex, and if you spend too much time on some marginal improvements, you might not have the time to solve the real problem. So it's good to just always keep in mind what are we trying to solve here. Next point, mark your assumptions. So your experiment will prove or contradict your hypothesis, but under some assumptions. You are building software, so you have some assumptions for sure. You are designing something which is reproducing reality, but is maybe not the reality. So it's good to really note these assumptions, because this would help you to know where could be the weak points of your approach, and you can challenge the assumptions later. So I'll get back to this later as well. Next point, you would need to do experiments. So even if you cut down many of the experiments, you would need to conduct a lot of experiments. So if you have the infrastructure for actually doing these experiments quickly, this will benefit you. And then again, if you have, again, we have software systems, and we could benefit from the same practices that we use for software systems. So modular approach. So we can understand better our system. We can replace parts of the system without actually touching other parts. This is also helping us in regards to speed. And the last point, correct evaluation of results. So not to forget, we are on this cycle. We did the hypothesis. We tried to challenge it. It seems sensible. So we continued with an experiment. We implemented it. We did the experiment. We have the results. Well, congratulations, we are now there. We need not to forget, though, to derive insights from these results, because this will push us to our next experiment. So not to forget to actually interpret the results, and also to do it correctly, because it might be not trivial to know how to interpret the results. Your system is complex. There might be multiple metrics that you need to evaluate. Okay, so this was a bit vague, probably. Therefore, we did a practical example where we tried to depict how you could use these practices in a cycle, in an algorithm engineering cycle. in a small dummy example, let's put it that way. So we are confronted with this problem. Develop a system that differentiates between images of cars and trucks in less than 500 milliseconds. Yeah, so first we are looking for the state of the art. So instead of trying to implement some super cool edge detection algorithm, we dive into the literature and find out that actually convolutional neural networks have been achieving the best result. So we can go into that direction straight away. We work in a team, so we discuss different hypotheses and how we can go forward. And here's a hypothesis that we had. So what about if we take a pre-trained neural network model based on the architecture there in this paper, and this will be good enough to provide a solution for our problem. So this is a hypothesis, right? But it's a bit broad. Would it provide solution for all problem instances, like for all images? This will be very hard to verify. Therefore, we can extend it with implementation with this pre-trained neural network model would provide sufficient solution for the data set X, for this specific data set. And we will use actually a very small data set, as we will see in the next slide. And we can play a bit with this hypothesis. We can negate it, for example. So we can say this, like if we start with this approach, if we try to use a pre-trained model, neural network model, with this architecture, it will be absolutely not possible to have a good enough solution for this data set. It will not be possible, or it will not work. This is our hypothesis. So we can conduct an experiment for this data set with this model, and then we can see, and we can contradict the hypothesis, which in our case would be good, a good thing. Okay, so we go forward with marking assumptions. We conduct our experiment with extremely small data sets. So data set has only 10 elements, so 10 pictures of cars and then pictures of trucks. This is obviously very small. There are no other big objects on the images, and there are no conditions impairing visibility, so weather conditions such as like rain, snow, fog, and all the input images are at daylight. So after we do the experiment, even if we succeed and we see that, okay, this approach works, we know that, well, this approach works under these assumptions. And we can inspire ourselves from the assumptions how to do the next experiment, how to go the next cycle of the next cycle for engineering the algorithm. We have infrastructure for fast experimentation, so we parameterize the code to, with press of a button, to use the set of cars or the set of trucks as an input. We have modular approach where we have different functions encapsulating the logic for the different parts. So one function for reading the data, function for inferring, interacting with the model. We have tests, so we can replace some parts and see that it's still working. And then we have our results. So we see that the classification with this model, ResNet 50, because it has 50 layers, the neural network, which was already pre-trained on the so-called ImageNet dataset, has absolutely perfect prediction accuracy on this very tiny data set. And the inference time is rather small. So we are in the time frame of 500 milliseconds. So we contradicted at least the negative hypothesis. It's not possible to do this with this approach. So we can then even go further and maybe challenge some of the assumptions and say, okay, let's try with 100 images or with 1,000 or with 10,000 and see what happens then. We look for some more justification for these practices. And one way that we imagine could justify it if we look in some papers which are popular, and if we look if these practices are used somehow in these papers. And we looked into 3 papers. The second one, for example, is a very popular one from the computer vision area. And all these papers have more than one author. The results have been presented in very clear manner. They focus on the main problem. So you could say in some way that these practices are used. All right, so final thoughts for me. I think process matters, and hopefully this presentation, if nothing else, would provoke you to think about your process. How can you improve it? Thanks. And yeah, hope now we can have some questions.
Hey everyone. If anyone has any questions for Luben, please either unmute yourself, or you can also write in the Zoom chat or the Twitch chat, and I will relay the question to him.
Hi, I do have a question. Maybe I missed it somewhere, but why did we go with a negative hypothesis that states that solution will not be possible to fix this problem? I don't remember the exact hypothesis.
Sure. So you don't have to. You can also work with the other way around. You don't have to negate it. It's just if you negate it, then you go with the attitude, okay, this I want to work, but actually I assume it's not possible, and I'll do the experiment. And if the experiment shows that it is possible, then I contradict the hypothesis. So it is easier to contradict something sometimes than to verify it, that is uniformly right, if that makes sense.
Yeah, thanks.
Any other questions? There's no questions in the 2 chats. I assume that's a sign that the talk was very clear, and thank you, Luben, for the very interesting topic.
Well, thank you as well for having me.
Our next speaker is Vinicius. He's a backend developer with a focus on Python for the last 6 years. He's also very into QA. He's currently working as a software engineer at Zion Technologies. He also contributes to the community by translating the Python documentation to Brazilian Portuguese. He studied electrical engineering and software engineering, and also loves craft beer and riding his bicycle. Vinicius, the stage is yours.
Thank you. Okay, let's do it. I'll be presenting now about better functional tests with APIs and BDD, or behave. Well, since I've been presented, I'll just skip this part, or just one small request. Anytime you go outside, please wear a mask, because the pandemic's still going on. Lots of people don't wear masks, so please do when you're outside at least, and wash your hands as much as you can. About the motivation for this presentation. Once upon a time, JavaScript, a front-end bug, slipped through our quality process and made its way into production, making it possible for a customer to achieve what he wanted. If I'm not mistaken, he couldn't edit or create a new domain, I guess. After we fixed that bug, one of our software engineers decided to find a way to prevent that from ever happening again. And then we started to implement functional tests. And then there was Caffeine. Caffeine is the project name that we created at Asium. It is a solution based on Test Cafe framework. Test Cafe is a JavaScript testing solution similar to Selenium, but better, slightly better. And it was a major breakthrough for testing and quality at Asium, but as time passed, we started to notice a few difficulties with it. One of them, I might say, is that the tests started to get a bit corrupted. Let's call it that way. And to better explain what I mean by corrupted, I'll quickly explain part of our stack. We have a big software which is responsible for handling the user interface and the APIs to our services. And after it, there is a dispatcher to pass information along. And that software is responsible for sending what is necessary to our edge machines. And the edge machines, of course, have lots of other softwares installed on them and are used by our final customers. Soon after we created Caffeine, we started to wonder, can we make some tests that actually test the response from the edge machine? We can, and in fact we did. And that might be one of the points where Caffeine started to drift off a bit from its original purpose. And testing the edge machines might not have been that much good of an idea. And some of you might ask, okay, but why don't you just stick with testing the user interface? Why not just unit test it? And to be honest, this image explained very easily. It's because our software, part of it at least, the admin interface, is a monolith. Everybody knows, use it, or love or hate a monolith. Maybe not that guy that's facing the horizon thinking there might be a better solution. In our case, the monolith is a Django application that's been going on with something like 6, maybe 7 years, continuously going on, receiving new features and fixes. So everybody that programmed with Django knows it's hard to test JavaScript or just the front end itself. One thing that we also notice is that the user interface is just subtle changes break the tests very easily, like changing any specific HTML elements to fulfill UX or products department needs start to break the tests. In this example, just replacing a specific list outside of div elements already broke tests at least once. And changing CSS also have the same effect. There have been maybe 2-3 times, something like that, where a developer refactors CSS classes with good intentions, but ended up breaking the tests. For example, just renaming RTM table content to table content was enough to break the functional tests. And we use CSS selectors a lot, but they don't produce code that is very, very readable. Just by looking at this snippet of code in the left, you can't quite tell exactly what is being selected during the code. So that makes it hard to understand. And unfortunately, there are not many good alternatives to that. We could, and in fact we do, leave some comments on top of the CSS selectors, but that tends to make the code bloated, long, instead of having maybe just 1, 2 lines of code, we end up with 5, 6, sometimes more lines to explain what's going on during the test. And we can also use get elements by ID, which is a good idea, might be a good idea, but sometimes we have to go back and actually change the code that was produced to actually test it in a functional test. In some cases, maybe to some mistake of the developer passed during the code review, tests kind of rely on each other. For example, most of the times during the functional tests, we usually clean everything up, then create an entity, edit it, then delete, etc. So it's very common. There are a few, I think 2 or 3 scenarios where if you run the complete test suite, that's okay, it works great. But if you try to run just a single test, then it already fails. And that is because sometimes the tests are kind of chained together. You have to first create a domain, for example, to later on be able to edit it. The tests takes a while since we're waiting for a response from a specific machine, and then cannot be run in parallel. They take forever, mostly due to lots of interactions, like the server needs to decide what's going to be rendered to the screen, so it wastes CPU. There's a lot of stuff going on over the network. The browser needs to render what has just been received. So it would be really cool if it could run the tests in parallel, like we do with unit and integration tests for the main project to reduce the execution time. But in practice, we cannot do that because usually we run the tests against a stage infrastructure. So it's very possible for 2 developers at the same time run 2 different instances of the test execution. So they end up having a side effect on each other. They are hard to program. Even if the person writing the tests has some experience, they take some while because mostly due to response from the edge machines. And we're not exactly using standard HTML components. So you have to dig it up exactly what's the code that's necessary to pick specific elements and interact with them. So among running the tests 1, 2, 3, 10 times, that takes a while and sometimes ends up using a lot of time from the developer. Readability does count since there are lots of teams working in the project. So the architecture kind of got a bit out of control. So as I mentioned before with the CSS selectors, that makes the code hard to read and to understand. So as it is said in the PET 20, beautiful is better than ugly, simple is better than complicated, and mostly important, if the implementation is hard to explain, then it's probably a bad idea. And one thing that we notice a lot, at least my boss asks me a lot, where's the report? Where can I see the problem? Not everybody have access to GitHub or GitLab logs, which is where the execution from Caffeine is kept today. So moving on from our current user interface testing, then we started with a new approach that might be more stable and is actually bringing a lot of more interesting results, which is use APIs and BDD. So APIs, probably everybody used it, read about it, wrote 1 or 2. So this is not the biggest focus of this presentation. I'll stick more with the BDD itself. Our objective is to better explain our business rules. BDD stands for Behavior-Driven Development and is implemented using the Gherkin language. Gherkin is a domain-specific language originally proposed by the Cucumber lib, which helps to describe business rule in natural language without going to any details of the implementation itself. It's also very common to confuse it with the classic user story formats due to its structure, which is quite similar. Something like a user or profile desires something to achieve a specific result. In practice, BDD, as well as tests in general, are made up of preconditions, which is prepare everything you need to run a specific test, a trigger, which will be awesome if you have just one, but sometimes people write BDD with more than one trigger, and specific post conditions, which is check with assertions that our desired state was reached. To implement functional tests, we do not use the Cucumber language because it's for Java, but there are several other implementations for each language. With Python, we are starting our BDD with Behave. It has three basic parts, which are the features, the scenarios, and the steps. Features are mostly just aggregators or umbrellas to indicate which module or macro functionality is being tested. The scenarios is the name that indicates what exactly is being tested. And finally, we have the steps, which are the sets of individual actions to be performed during a test. They are the ones that actually are responsible for calling the Python code. I wouldn't be able to bring a whole complete scenario, so I just brought up a single step over here because it wouldn't fit a whole slide. We can see that the BDD itself, the step, is mapped to a Python code, in this case, the given, using a decorator. It says which part of the BDD is being used, and we pass along a parameter with a string with its description. In this case, we're about to log into our API, setting everything we need, getting back a token, and other informations that you need to carry on along the next steps or other tests maybe is used by creating variables in the context. Another great advantage of Behave is the features and the scenarios themselves already act as a report for the test execution with great readability. We even have the time where every step used during its running. It's very important, at least I think so, that each step executes one and only one action. So if by any chance the step fails, then we already know exactly what's the problem and what's going on to work on that. Another interesting feature that Behave and BDD is helping us is to document our business rules. Like the idea is to have a live documentation. For example, when a new feature is created or we are making a test, then that already allows us to also and automatically update the documentation. So, but why the APIs and not the UI itself? Mostly due to stability. If we make a change in the user interface, then the customer can adapt, work around of it, for anything that was generated. But with the API, it's not like that. Every REST API that is available defines a specific contract with very specific rules. So we're accepting or waiting for these fields with this URI, and we'll provide this result. If you make any abrupt changes into the API from one day to another, then it's probably that we will cause trouble to the customer, as well as the automation that we have or the customer have. So we have to take a lot of care with that, like use version control for the API, protect with client flag, or other alternatives. Other benefits that we are noticing among this new approach is that it's starting to help us to decouple the front end from the back end, break the monolith, test exactly how the customer is using our APIs, thinking about developer experience in UX. Like, long gone are the days when our clients use it only and only the user interface. Nowadays, everybody wants to do automation, so it's very important to test your APIs. And even more important is better integration with other departments, for example, the products department, into creating test cases. Like if we find a specific bug that was not documented in business rules, then write a test on it, and it's already documented, and fix it. One question that I got back at Asium is if we should stop testing the UI. Definitely not, we should not, but we can work on it and improve the way we're testing. Maybe getting back to its original purpose of testing just the JavaScript code itself. Oh, who knows, maybe fill it up with a lot of mocks and focus just on front end. And what's the current status of the whole project? Right now, it is located along with the monolith. Particularly, I'm not proud of it right now. This decision was made with the good intention that when a pull request was merged, we can actually trigger the complete test suite inside of the APIs. So this has not been done yet. Nowadays, it is executed daily with GitHub Actions, scheduled to run at 2 p.m. or 3 p.m. during nighttime when nobody's working, lower payload. So we just arrive in the morning and check if there are any notifications on Slack to see if the tests broke for any reason and investigate. And again, as my boss asked, where can I see the generated results? So this is one of the focus that we worked with this new approach. I don't know if anybody ever heard about Allure. I think that's how we pronounce it. It's an open source software for hosting reports. It's very interesting because we can see tests failing, trends, and very interesting data. I recommend if anybody have time to check it out. It's very easy to set up using Docker. Some other alternatives that I stumbled upon during this whole new approach. Originally, I checked it out to use Report Portal, but it seemed a bit more complex than Allure. So it's interesting. You got some batteries included, like AI to try to predict which tests will fail, so something like flaky tests. And this has not been executed, but it is on the radar to check if the tests run in parallel. Today, they're not running in parallel, but there is a library called Behave Parallel, which I'm particularly not that interesting to use. I'm a bit suspect about that because it has not been merged with Behave until today. I don't know if it's something like discussions in the community, something like that. And the last committee that received it was about 5 or 6 years ago, something like that. Or either is very, very stable or it's deprecated. But besides Behave Parallel, we're considering maybe migrate in the future to PyTest BDD, which enable us to run the parallel execution of PyTest. But interestingly enough, I don't know, Behave is more popular than PyTest BDD. I think it's because Behave is easier to set up than PyTest BDD. Well, to wrap it up, I assembled this little table over here that shows off that we had some difficulties with caffeine, and Behave is being very, very awesome so far. And a final advice that I recommend to anyone that is developing a new product, whatever you do, make it API first, because it'll make it very, very easy to test anything that you'd like. This is not in the Bible, just quoted here for fun facts to call attention. Would like very much to thank you for the opportunity for presenting here at PyBerlin. Thank you very much. Obrigado, gracias, vielen Dank, arigato. Still working on Chinese and Russian. If you can pronounce it, please do. A special thanks to Morgana from the design department to help me out with the design of the slides on the last days of the presentation. And if you have any questions at all about QA, software development, beer, riding a bike, please feel free to contact me. Thank you.
Thanks to you as well, Vinicius, for presenting this interesting approach. If anyone has any questions, please unmute yourself on Zoom and ask the question directly or post it in the Zoom chat or Twitch chat. Samira is asking, you mentioned that the tests are scheduled to run in the night with GitHub Actions. Why schedule them?
Mostly to prevent any possible bugs to enter in production, since they are working on our stage environment. So we don't forget to run them before any deployment. So just to keep an eye on that. We could run them manually, and we do a few times when we want to check something out, but having them scheduled help us to prevent us from forgetting before deployment.
I have a question. So when you talk about API first, is there a good way to do this with Django?
Sure. Mostly the decision between going either with the interface or APIs is up to the developers, the company. In our case, the APIs arrived after some parts of the software. So nowadays we're working on having new APIs. I think the recommended way with Django would be with Django REST framework, which is not part of the main Django package, but it's easy to work on it. There might be some other approaches besides Django REST framework, but I think it's the de facto approach, let's call it the default approach for APIs and Django.
Thanks.
Jose is asking a follow-up question on the one regarding the scheduling of the GitHub Actions. He's asking why not running them before a pull request, something like CI/CD alike.
We could. In fact, we can. That's probably the original reason that I'm thinking about why we did it into the main repository. You asked running before, mostly because since some of the tests hit the edge machines, we don't have a specific infrastructure with all the branches on GitHub. We have a bit of a difficulty into raising all the necessary infrastructure, the edge machines. But usually we could, for example, immediately after the pull request is merged, the code goes to a stage environment, and you just wait about 3 minutes, something like that, maybe 5 minutes at most, and it is already available on the stage environment. After that, we could automatically run the API testing with PDD. But as it is right now, before the pull request is merged, we're not able because some of our tests rely on infrastructure.
And I would have a question maybe regarding testing an API generally. I recently heard about a tool with which you can automatically test an API if you have an open API definition. Do you think this is a useful approach, and or does it have downsides compared to the approach you presented?
Might be a good approach. I'm not particularly sure about this tool. I didn't get the name of it. Would love to hear it, of the name. But automatic test case generation is very interesting, for example, into fuzzy testing, like hit your API with as much garbage as you can and see how it reacts. But this approach in specific with BDD we are also interested in documenting our business rules. So it generates less test cases, but they are very target specific. Like we know this scenario should have this specific response.
Yeah, thanks. The tool is called Schema Thesis, I think. Haven't used it yet, but it sounded good.
Cool.
And Jose also mentions that Postman offers a way to do mock servers or tests based on an open API definition.
Awesome. That will be very interesting. We don't particularly document our whole APIs with open API standards, so that is something we're also trying to check it out.
I would like to thank you once again for being here tonight and taking your time to do this presentation. And then we will just go over to the closing session. So yeah, thanks for joining this year's second PyBerlin event. And thanks to our two speakers today for the very insightful talks. And thanks again to our sponsor Scoutbee for the premium Zoom account, which we used today. Our next meetup will be on March 10th, 2020, and we'll have as a special occasion International Women's Day. And everyone is very welcome, as usual, to contribute to PyBerlin, and we can always use some extra help. So please reach out to us if you're interested in helping out. We're also looking for speakers or panelists, so please reach out if you have a talk, an idea of a talk you want to give, or anything you want to hear about. You'll find a form under this link. And don't forget to follow us on Twitter, spread the word about PyBerlin, and feel free to join the Berlin Python community Slack. That's it for today. Enjoy the rest of your evening. Take care and see you next time.